morning children. In today's class, we are going to learn about Statistical Quality Control, shortly called as SQC. Quality. Today, the most wanted word. Yes, even if you get one biscuit, it should be of the great taste that you want, it should be of the size that you prefer, and it should be of different varieties. So, quality is expected right from a minute product to even a Benz car. Now, the statistical quality control, what does it do? Right from getting the raw material till the final delivery, there will be problems. So, the industrial concern should meet with all such problems encountered and they should give a quality product out. The product should meet the consumer's expectations. So, this is the main idea of SQC. In all the business concerns, SQC, when I say, it depends on 4 M's we say. What are the 4 M's? First M, material. The quality mainly depends on which type of material we get. Number 2, it is depending on manpower. The next M, manpower. So the labor who is working towards it, their interest, their dedication actually gives out a better quality product. So the product is actually depending on the labor, or I can say the manpower who is doing that. Number 3, we depend on the machine. The machine should be of a very good quality to meet the needs. So the third M is machine. The fourth one, the management. The management should control the entire process. They should motivate and they should also give some time to check the quality. So, statistical quality control depends on 4 M's. What are the 4 M's? We have material, manpower, machine and management. Statistical quality control, or in short SQC, is a powerful technique in controlling and checking the quality of a product. It helps us to diagnose the lack of quality, how much it is reduced, in what way it can be made up. So, it helps us to diagnose the lack of quality. Number 3, I can say it ensures that the end products are to meet the consumer expectations. So, SQC is mainly used for 3 different things. It is a powerful tool and a technique to check the quality and to diagnose the lack of quality, and it ensures it meets the consumer needs. SQC is a technique that is used in almost all the production industries, right from biscuit industry to a very great manufacturing industry like cars and mobiles and everything. We are using the statistical quality control. Now the question is, why there is a change? What type of changes are there? The variations are mainly happening due to 2 different causes. What are the 2 causes? Number 1, by chance it has happened, we say. So, it is a chance cause. So, very first one, it is a chance cause. The chance cause is a minor cause. It is mainly due to natural forces. I can say rainfall or flood and mostly power cuts. So, these are minor effects that affect the quality. So, this we call chance causes. The next idea we say assignable. The word itself tells I am able to find out why, where, when, how. So that is the reason for giving the name assignable. I am able to assign why it has happened. I am able to assign who has done it. I am able to identify which product is not of good quality. So assignable cause starts right from the arrival of the raw materials to final delivery of the product. I can say assignable causes are there. Assignable causes, mainly we say due to defective raw materials received. Raw material itself may be defective. That is the very first thing. And machinery may be fault. The machine would have not done properly. The machine would not run properly. The correct timing. So whatever is set, the battery, the charge, anywhere the machine, the problem may be there. So that we say fault in machine. The next idea, the skilled labor may not be present. The one who is efficient may not be there. So the one who is able to identify may not be there. So unskilled labor may be a reason for assignable causes. And finally, worn out tools. The tools itself may be worn out. So that is also a reason. And sometimes, very rarely we say new operations are also assignable causes, because new operations when we do, we may not know whether it comprises of all the qualities, whether it ensures what we expect. So new operation also sometimes can be coming under assignable causes. So in statistical quality control, we mainly discuss there are two causes for variation. Number one, chance causes, and number two, assignable causes. Chance causes are due to natural forces. So, chance causes cannot be prevented or they are beyond human control. But assignable causes, just by the very word, we are able to assign what, when, who, how. We must be able to eliminate. So how are we going to do it? Assignable causes are eliminated through this technique called SQC. So the main purpose of SQC is to devise a technique to eliminate the assignable causes and to bring about the production process under control. So SQC tries to bring about the production process under control. Now we have two things: product control, process control. So what is process control? We are trying to maintain a satisfactory quality level. So in process control, we are trying to maintain a satisfactory quality control, and this is done through control charts. Control charts we will discuss a little later. So process control is mainly done using the technique called control charts. And the main idea of process control is to minimize the proportion of defective items. To minimize the proportion of defective items. The next idea we say product control. Product control tells controlling the quality of the product. Here also we say controlling the quality of the product by critical examination. So we examine through with sampling techniques. So by critical examination through inspection plan, we ensure this product control. And product control mainly aims to guarantee the customers the quality level. Control charts. What are control charts? To check whether the process is maintaining a standard quality level and to reduce the variability, we are using the technique called control charts. Shewhart's control charts provide an answer to both. Shewhart's control charts aim to detect patterns of variation in the data. It is simple to construct and easy to interpret. The Shewhart's control charts, we are drawing two different types. One is X bar chart and the other one is R chart. Each chart is containing three different lines: CL, UCL, LCL. Let us see to it now. What are the three different lines? First one, what is my desired level? That is called central line. And upper limit, how much can I say okay for it? So my maximum tolerance level, upper control limit. down it goes. How much I can say okay for it? My lower control limit, or I will say the tolerance limit at lower. The tolerance limit at upper level, the tolerance limit at lower level. But CL, control line, is the desirable standard level. So a control chart has three different lines. We call them as CL, UCL, LCL. CL, central line, UCL, upper control limit, and LCL, lower control limit. Actually, CL is the desired standard level of the process, and UCL tells me my upper limit of tolerance, and LCL tells us the lower limit of tolerance. Now, where you see the three control lines, we draw it in the control charts. How many control charts are there? Two control charts we are drawing. Number one, it is a mean chart based on X bar. And number two, it is the range chart which is based on the range. What do you mean by mean? Average of the scores or average of the data that I am analyzing. What is range? Upper minus lower. See, when you go to shop, you don't tell exactly 400 rupees I want something. You tell, show me the range from 300 to 500. Then you can decide which one you want. So here we are having two different control charts. Number one, mean chart, or we say X bar chart. And number two, range chart, or we say R chart. These charts are mainly to check the quality control. Control charts, when can we use them? Whenever a quality characteristic that can be measured quantitatively. A quality characteristic that can be measured quantitatively, we can use control charts. Now, length, width, strength, temperature, this, which all I can measure quantitatively, I can use control charts. The very first idea, mean chart. What all should we know about mean chart? Mean chart is to show the quality averages of the samples taken from the process. Mean chart is to show the quality averages of the samples taken from the process. Number two, the control limits. What we draw, the CL, UCL, LCL. They actually tell us whether assignable causes are present or absent. The control limits help us to identify whether assignable causes are present or absent. Number three, it helps us in decision making. Yes, with control limits, I can decide whether I can accept the process or I can reject the process. Now, what is the statistical calculation that we need to draw the X bar chart? Mean chart, I can draw in two ways. Number one, X bar and standard deviation, that is mean and standard deviation for the data are given. We have the set of formula. CL is X double bar. X bar is mean. X double bar is mean of mean. Average of averages. UCL. UCL is upper control limit with X double bar. Add 3 times sigma by root n. Then what will be LCL? Instead of adding, subtract. Remember the sigma by root n, we call it for standard error of mean, which we learnt in the earlier chapter. So remember, for UCL, you can add 3 times of sigma by root n, and for LCL, you need to subtract 3 times of sigma by root n. Once I know the 3 different control lines, check whether all the data given in the question are in between the 3 lines. Any one value goes outside. that is beyond, either below the LCL or above the UCL, we will immediately say the process is not in control. Now, how to draw X bar chart when they do not give X bar and standard deviation? They will give you A2 in that case. So, A2 will be mentioned in the question. How to find out CL? As usual, X double bar. X bar and R will be given in the question. CL is X double bar. UCL is X double bar plus A2 times R bar. A2 will be mentioned in the question. Or even you have a table in your textbook to refer to A2 values. LCL is X double bar minus A2 R bar. We need to remember the formula to apply for drawing LCL, UCL and CL and to check whether the process is in control. The next idea, we proceed on to range chart. What is range? Range is maximum value minus minimum value. Given a set of data, you calculate the range, finding maximum minus minimum. Once I know all the range values, find the average of it. Call it as R bar. Once I know R bar, D3, D4 will be given in the question. You find out R bar as central line, D4 R bar as UCL and D3 R bar as LCL. Suppose sigma is given or you are able to find out what is the standard deviation of the range values which we call sigma R. You can write UCL equals R bar plus 3 into sigma R. LCL is R bar minus 3 into sigma R. And CL as usual it is R bar. What is R bar? The average of all the range values. R stands for range values. The next idea about R chart. What all we said in X bar chart, the same ideas we will say once again for R chart. Then main differences in R chart. We are actually showing the variability of the samples. In X bar chart, we say the quality average of the samples. In R chart, we are expressing the variability or I can say the dispersion of the samples taken from the process. Number 2, already we said this also helps us to identify whether assignable crosses are present or absent. Number 3, this is also required to decide. So it helps in decision making whether or not we can accept the process. So in all the problems, once I draw the X bar chart and R chart, ensure all the given data values are inside the 3 lines. Even if one point goes beyond the line, say above the upper line or below the lower line, immediately we will say the process is beyond control or I can say the process is out of control. So, control charts, an effective tool in statistical quality control to check whether the process is in control. Let us proceed with the exercise problems.